Okay, so here we would like to use the Newton Raphson method in order to estimate the root of the equation x cubed plus x plus 3 equals 0. So let's recall that if we want to find the root of the equation f of x equals 0, then we start with some number x naught and use the next step, if we have one step xn in our hands, is xn minus f of xn over f prime at xn. Now, here we have to be careful. If we have multiple roots, then we have to be able, depending on where we start, to predict where we're going to end. This is a very sharp method. It will converge very, very fast. In our case, we have a very simple application because this particular function has just one root. As we can see, it's an increasing function. Its derivative is 3x squared plus 1. It's always positive. It's an increasing function. By the intermediate value theorem, it has a root. So we're going to just go towards that root by using the Newton Raphson method. So let's solve this. In general, when we use the Newton Raphson method, it's a good idea to actually find the general formula for the Newton Raphson method, simplify it if possible, if there is some easy simplification, and then use it for all of our steps. Okay, so here we need to define, so we define, because we start with no function, we just have the equation, x cubed plus x plus 3, and of course, this has derivative 3x squared plus 1. So this will mean that xn plus 1 is going to be xn minus, so we have on the top, we have f of xn. So that would be xn to the third power plus xn plus 3. And on the bottom, we have 3xn squared plus 1. I'm not sure that we can do a very fancy simplification here, but let's just give it a try. So if we clear denominators, we will have xn times 3xn squared plus 1 over 3xn squared plus 1 minus xn cubed plus xn plus 3. We could very easily work with this without simplifying anything, but let's just do this. So we will get 3xn cubed plus xn minus xn cubed minus xn minus 1. So we apply the negative sign to all the terms of this fraction right here, of the numerator of this fraction, and the denominator is 3xn squared plus 1. So what do we get? We get 2xn squared. Xn minus xn cancel each other. So 2xn squared minus 1 over 3xn squared plus 1. Okay, so we're doing two steps just to illustrate what is going on. So we found that xn plus 1 is equal to 2xn squared minus 1 over 3xn squared plus 1. And we start with, we said we start with x naught equals 0. And if we plug in x naught equals 0, we find that x1 will be 2 times 0 squared minus 1 over 3 times 0 squared plus 1. And this would give us minus 1. You see how the method already directs us toward negative numbers. And this makes perfect sense, because if you look at this equation right here, it cannot possibly have a positive solution. So the method already directs us toward negative numbers. Let's find just one more step. So x2 will be 2 x1 squared minus 1 over 3x1 squared minus plus 1. I should have written it before too, that what I computed here, this was 2 times x naught squared minus 1 over 3x naught squared plus 1. So I'm just following this formula right here. Okay, now that I know that I have 1, I will get 2 times 1 squared minus, negative 1 squared minus 1 over 3 times negative 1 squared plus 1. So this will be 2 minus 1 on the top and 4 at the bottom, which is 1/4. And that's our next guess. So, of course, now you might wonder about the comment that I made before. So I said that this throws us directly into negative numbers. However, what I want you to understand is that this method will usually take us back and forth. So if I were to just try to draw it, I might get something like this. So you can see I started with 0, that threw me to negative numbers, and then the next one could possibly take me to a this figure here. Actually, I think it still takes me to a positive number, but all I'm saying is that you can see that we're going back and forth. So this picture is not so helpful. But in any case, that's the second estimate that we're getting. And if we were to take a next step, most probably we would get a negative number. You can see it when you put 2 times 1/4 squared. That gives you a pretty small number, 1/8 minus 1. That will throw you again into negative territory. And eventually, after a certain point, everything will stabilize into negative territory. And that's all. Thanks for watching.